So I'm going to demo some of the terrain and height map nodes I've added to my library. It starts with this create terrain node, and this just creates a blank canvas to start working from. It's just a simple mesh plane, but it has been created in a specific way that will work with all these other nodes. So a generic mesh plane will probably break things. Obviously, since this is intended to be a height map, we only want to manipulate it in the y-axis. So for this, there's a specific set terrain height. So if you just want to ensure that you're only moving it up and down, you can use this node. But just for an example, I could use fractal noise. I could use a fractal noise field with this. And this is a very large plane. I should mention a lot of these nodes, the kind of default parameters are set up to be in like the kilometer range. Most of the stuff assumes that 1 unit is 1 meter. So this plane is 2000 by 2000, which is to just say it's basically 2 kilometers by 2 kilometers. So it's going to be really big to start out with. So the default noise, I'll need to drop the frequency by like a factor of 1,000. But yeah, now I've got basic height displacement. Nothing too crazy here. There is a node I set up. It's called Voronoi displaced terrain. So the default values will be something like this. If I click on this node and go to the coefficients, it's sampling the Voronoi pattern. Basically, these are the 4 closest points, and then they're added onto each other with some coefficients. So these are arbitrary, but these defaults kind of give some kind of mountainy shapes. But I could click and add a few more and just kind of pick random values and see what happens. Kind of the more values that are added, the smoother it'll get. Of course, this, as is, looks kind of not so great, but that's what this displacement is for. So I'll create a fractal turbulence field. And again, I'll need to drop the frequency by like an order of 1,000. But this displaces the points before sampling the diagram, and that gives a way more interesting effect. So yeah, eventually you can get some pretty convincing base kind of mountains. This gives like nice valleys, but flipping it gives like nice like ridge mountains almost. So this has a scatter node inside of it to throw some points down. If I wanted to manually create points in a very specific way, I could do that with this port. But so long as nothing's plugged into this, it's just going to default to the internal scatter node. And so there are the basic controls for that here. I can set this if I want, fewer mountains. I can set that to a lower number, and if I go higher, I'll get more. Basically, it's essentially like the frequency of the noise, but I think a value of 20 is a good place. And this is a pretty slow node, so I'm just going to throw down a cache value. And what this node does is it just does as it says. It just caches whatever you put into it, and it's not going to continuously update unless I check this update box. But as long as this is off, it's not going to be recomputing all of this stuff. Now, if I put down a terrain to height map, this converts the terrain into a OpenCL image buffer, and now we can do stuff to the terrain on the GPU. And so if I view this, I get nothing because now it's just, again, it's just image buffers on the GPU, nothing to show. But the point is, all these GPU related nodes are going to be much, much faster. So the icons kind of indicate if you're dealing with a height map or terrain. Of course, if I want to get back to it, I can just do the inverse height map to terrain. And now I'm back to standard Bifrost geometry. And this has its own diagnostic, so I can just get rid of that terminal port. So for starters, let's say I wanted to add some feature manually, some very specific shape. I'll start with creating a height map, or project height map, I think. Project to height map is what it's called. And this lets me take a mesh and project it onto the height map. Just plug that in, and I'll go ahead and switch the cubes display to kind of this wireframe. So I'm actually just seeing the actual height map. And now I've got a cube, and wherever I put this, it'll show up. And yeah, you can see if I lift it up, it is in fact being projected on there. And again, this is something you could do. I could do this in kind of the terrain with the terrain directly using standard Bifrost nodes. Just doing it on the GPU will just make it a little bit faster. So in addition to that, I can also output a mask. So a height map is going to have an image buffer for the height itself, of course. It's also going to have a second buffer for a mask, and that's just used by effects if you want to only affect a certain part of the height map. So right now we've got no mask, but I can go to this and set the output of the mask to hit. So wherever there's a hit, it will fill in that pixel with white and leave everything else black. And that's just being displayed through this this conversion node. So I've shown mask enabled, so it's just coloring that part of the map with blue. And I can also, for example, set to delta unsigned. So this is just going to output the absolute value different. So how much was the pixel moved by the projection. And you can see everything turned purple. That's a kind of a diagnostic to show where the mask is clipped. Now let's say I want to do some basic fixes to that. I also don't like how the whole terrain is kind of shifted down below the grid like that. There's a node called height map expression, and this is just for doing like simple manipulations, arithmetic. Maybe you want to like clamp above a certain value. And this lets you kind of write an expression, kind of like a mel expression almost, that will get executed for each pixel. So there's 3 sections. I mean, this part down here is the advanced section. This is the actual source code, that the actual kernel code being executed in full. So this is everything. These are some helper functions and some constants, and then this is the actual function body. So it reads in, the height, and it has a height out map. Reads in kind of some standard values. So this h0 is going to be the start height, and then the h is going to be the output height. So whatever this h ends up being set to will be written to the map. And then these are where the expressions get subbed in. So it's very simple. So if you wanted to do something very specific and very custom, or that required like for each loops or like several lines of code, you could just go in here, edit this, and then copy and paste it back into the source code and just ignore all this stuff up here. 9 times out of 10, I just want to do some simple like scaling or clamping of values, and so these work out great for that. So there's an expression to set the height. So whatever this evaluates to will be the new height. Whatever this evaluates to will be the new mask. And then the mask blend is just how to blend between the original height and the new height based on the mask value. And then I can decide which maps I want to actually write. So by default, the mask is not going to be modified. So if I do something like m times 0.1, it will apply to the mask blend, but it won't actually write that value unless I check this box. So if I actually want to see what that's doing, I can go ahead and just plug this in. And again, I'm not doing anything to the mask, but if I go ahead and enable that write, I can now multiply this mask to kind of like tone it down, because again, all this stuff up here is clamped above 1, but I can kind of multiply this by some value to bring that back into the 0 to 1 range. And typing in values is a little bit tedious. It's also might be hard to read, but in OpenCL, you always need to put an F at the end of a float value to indicate that it's a float and not a double. So whenever using like decimal points, you just have to put an F at the end. So if I get rid of the F and then try and do stuff to this, it's actually working. But certain situations, let me try here. Actually, this might cause it to freak out. Yeah, so this is an example where it's going to cause issues because it's going to give like an error. I can actually view the error if I want to. Check this out. So it's just telling me that it's going to be some, I guess like casting error. I'm mixing floats and doubles in a function where they all need to be the same. So for that reason, just kind of becomes a habit to just throw an F at the end of whenever there's a decimal point somewhere. But back to the point I wanted to get to. So yeah, rather than typing in a value manually, I can do P and then some value. So down here, there's these parameters, and this is just an array of floats. I can just add an extra flag, so now I have 2 parameters. You can see by default that first parameter is acting as a scale, and it's going crazy again because the mask is some crazy high value. But yeah, let's go ahead and set this to parameter 1. So I'm just multiplying the mask by this second parameter, so I can slide this around. And actually, if I go negative, this orange value, again, it's a diagnostic thing. Wherever you see orange is just indicating that the mask is negative. And so now when I slide this multiply around, things won't go crazy. Trying to find the perfect value is pretty tricky. Also, maybe I want the top to be clamped. So I'll go to that mask expression and I'll just literally type in clamp. I'm going to clamp between that value and between 0 and 1. So now all the purple's gone because I've clamped it, and I can kind of decide if I want this, or like how smooth I want that fall off to be. And then finally, as I mentioned, I want to actually shift this whole thing up. So I'll switch the height expression to plus the parameter, and now I can slide it up. The mask is in effect here. So to basically say I don't want to mask this, I can just go to this and just type an H. So it's kind of bypassing the whole masking thing, but I'm still modifying the mask and writing it for later use. But as far as this expression node goes, I'm just saying make height the final value. Now this object kind of sticks out like a sore thumb. So I'll start by just doing a height map blur to just blur it out. And you'll see a lot of nodes will have the option to whether or not you want to apply the mask. And generally it's going to be on by default. So I definitely only want to blur where that where the projection happens. So I'll enable mask, and maybe I'll go a little bit strong. Actually, I'll go a few more iterations, and that kind of melts into the terrain. And then to add detail, there's a noise, height map noise node, and this is just like Bifrost fractal noise, but again, it's just on the GPU, and so it'll be a little bit faster than converting back and forth. It also has this slope masking, which is a technique of kind of manipulating the noise, which just enhance the noise look in the context of terrain. So it'll add like ridges and divots that are just a little bit more terrain looking. In this case, I could go with or without, maybe just a little bit, but that's what these extra settings are here for. And otherwise, it's pretty much the standard noise related settings. So I can just tweak these around until I'm happy with the look. The last thing I'll do to this is the big one, height map erosion. And I'll also create an erosion scope to replace this. It basically does the same thing, but it has these coloring modes to show me what the solver is doing. And it is kind of a solver, so I'll go and rewind and then step forward a few frames and let it do its thing. And I can switch coloring modes, as I mentioned. So we're looking at the water right now, but I can switch to flow, or like terrain hardness, or the most importantly or most useful is these material hydro, material erosion. And this shows the changing or the movement of material for both erosion types. So wherever it's gray, it's been eroded or like subtracted from, and wherever it's brown, it's been added to, or where it's been deposited. So if I let this play a little longer, I'll see some more depositing happening. And you saw just there, all the water kind of disappeared. If I switch back to the water view, all the water is going away. So on the height map, or on the erosion solver, there is an option to set the end frame for rain. So there's the start frame and end frame for the simulation, but there's also an end frame for rain. And the idea is to kind of, let the rain fall and then stop, and then let everything reach equilibrium, and now you have the final height map. It's not necessary. If I wanted this to rain the whole time, I could do that. But if you want some kind of end state that's predictable and like repeatable, that's what that option's for. And this kind of gets into tweaking the parameters. So I like to kind of focus on one erosion type at a time. So I'll go down here to the thermal section and just disable thermal erosion for now while I tweak all the water stuff, or all the hydro erosion stuff. And generally the defaults are pretty much fine. Actually, I want to set this back to 20. These defaults are fine for me. The only thing is I'm not getting enough erosion. So I could extend the timeline and simulate longer, but simpler is to just increase the steps per frame. So basically just pressing fast forward, I'll go from 100 steps to 1,000 steps per frame. And now each frame that passes is basically 10x as much time passing. So, you can see the erosions happening much more aggressively. I'm seeing some instabilities pop up. If ever there's like weird artifacts happening, it's generally stuff's happening too fast. It's kind of equivalent of like not having enough sub steps in a simulation. So I'm seeing this is happening around like deposits. So I'll just go down and I'll I'll reduce the draining. So just a real quick cover of what these options do. So rainfall is how much rain happens per frame. And then the evaporation and draining are how rain goes away. So evaporation is just universal. It just subtracts water from everywhere. Draining is, it's kind of to prevent big pools from forming without having to crank evaporation up. Because if evaporation is too high, water won't even make it down the mountain before it's evaporated. So I can have evaporation low, but I can turn draining up to like something really high, and then it'll make these pools not form as deeply. It'll kind of like knock them out before they have a chance to grow as much. So you can see it's pretty subtle. I could actually even go higher. If I go really high on this, yeah, you can see now there's not even a pool forming, but we still do have water elsewhere. Now, draining is universal. It's based on depth, so it does affect everything, but the deeper the water, the more draining happens. So it is subtracting from everywhere, but it's especially subtracting from where these pools would form. But now I'm getting no pools, so I don't actually want that. And I think the issue before, if I go back to the default value of 002, is the draining was causing sediment to build up too quickly. So if I just reduce the draining speed, that should help alleviate that issue. However, it does mean this pool is going to get a little bit bigger than it was before, but I'm okay with that. And it still looks like there's 1 or 2 pixels that might be artifacting, and here. These will actually be taken care of by thermal erosion. So wherever you have like spikes or like artifacts like I was talking about, in addition to kind of tweaking settings, thermal erosion usually just knocks those out anyway. So I'm not too worried. I'll go ahead and just leave this for now. But while this simulates, yeah, I can go down the list. So flow is how fast it can flow, basically. So flow rate and gravity, just how fast it's going to flow down a slope. And then inertia is if it carries its momentum, so it can kind of go up a slope if you have a high inertia value, or if it's very low, it'll just kind of follow gravity more exact. So this should be between 0 and 1. Setting it too high or too low can result in artifacting, but anything between like 0.2 and 0.8 should be good. And then when it comes to sediment, this is how much dirt the water actually picks up. So the dissolve rate is just if water's sitting, moving through some channel, how quickly is it pulling stuff off? And then the capacity is just how much stuff can a given amount of water carry. As stuff is removed or deposited, it has effect on the dirt. So when stuff's deposited, it makes stuff softer, and when stuff's eroded, it gets harder. So the idea is it's like you've scraped off the, loose topsoil, and now you're down to like actual rock. And so the idea is, as you're scraping stuff, it's getting more and more difficult to take off more. And this reaches equilibrium over time. So if something's really hard now, after a few steps, it'll get softer and softer over time. And that's what these two values do down here. So the dry solubility is just kind of saying, if you left some piece of terrain be and just let it sit without anything happening to it, where would its solubility end up over infinite time? And so this is a value between 0 and 1. So 0 being completely insoluble and a value of 1 being really easy to remove. And then the drying rate is just how fast it reaches that equilibrium. So this is all a bit abstract. The best way to kind of figure out what are good values is just to switch this to the hardness and mess with those values and see what happens. So if I'm feeling like I don't want these channels forming so deeply, so easily, I can turn up the hardening rate to like something like 10, and you'll see everything just stops almost immediately. Like once it gets a little bit, these channels just stop getting any deeper. I could, rather than lowering this, I could also try increasing the drying rate to something really high. So it'll kind of get back to equilibrium. So now, yeah, I've set it actually too high. Everything's just pinned at equilibrium because it's drying too quickly. So I can actually drop this down. Actually, let me try 0.01. That might be a good middle ground. So yeah, that might be a little bit better. So this can, again, it's just kind of a thing to feel out through trial and error. I'm actually kind of liking what that's doing. So I'll go ahead and now disable hydraulic erosion. So just to focus on the thermal erosion. And so this is just erosion from gravity, basically. It's just like if you have a mound of sand and you give it a little shake, it'll kind of flatten out. And so these default settings are actually pretty aggressive for this terrain, but you can kind of see things are kind of turning into what look almost like sand dunes. So the slide rate is just how fast it slides. It doesn't actually affect kind of the convergence point. So if I set this to something really high, it'll just get there faster, but the slope will be the same. That's what this threshold handles. So given a pixel, look at my neighbors. If the difference in height is above this value, then I'm unstable and I need to start sliding. That's what this value says, basically. The threshold n, I'm just going to ignore for now. I'll come back to this, but for now it does nothing. And so basically, the lower this value, the flatter things will be. So if I lower this a bunch and then let it play, now it's going to turn the whole thing into it's basically just melt the entire thing into sand dunes. Now I'm smoothing things out. I really don't like, you're getting this like way too smooth and these like very digital lines that are forming. The thermal erosion is the only one that has like a way to, it's kind of not very intuitive, but basically I can write a buffer, like a noise buffer, to control how much stuff is being eroded, just to add detail. So the process for that, well, first off, if I just do write height map buffer, this node lets me take some Bifrost data and then write it to a buffer. So generally that's going to be either the mask or the height buffer, but in this case, there's kind of a secret one specifically for thermal erosion called thermal threshold. And that's where this threshold n comes in. So if this thermal threshold buffer is available, it's going to say values of 0, use this, and values of 1, use this, and then obviously interpolate everything in between. So there's a node called height map positions. And this just gets creates an array of points based on the height map. So basically sample noise is what I want to do. So I'll use fractal noise field, and I'll do sample field. And I can plug that into this. And I kind of want to see what I'm doing. So I'm going to copy and paste this, switch this to the mask buffer, and then get map to terrain. And I'll just hide this for a second So I can just to visualize what this actually looks like. So first off, a lot of negative values. I don't want that. I'm going to use a remap or a change range node. And noise is going to be like roughly 1.2 plus or minus by default. So I just map that to between 0 and 1. And I'll keep clamped on. Then again, the frequency needs to be like 1,000 times lower, or maybe not that low. Something in between is good. And I'll increase the octaves, maybe increase the ratio just to give it more contrast. So yeah, okay, I'm done with, or actually this should be plugged into this. I'm done with this. And these two defaults, I might lower this a bit, maybe like between 2 and 6. And so this should just give it a much more interesting pattern instead of just being these kind of smooth slopes. I might increase the slide rate just to see what this is doing more aggressively. Okay, and I think that's good for this. So I'm just going to lower the slide rate again to match kind of what the hydro erosion was doing. And I'll turn both on now, and I'll let this run for a bit and see what the final result looks like. Actually, I think the thermal erosion is still way too high. Okay, and here's the final result. As I mentioned, that thermal erosion really knocks down those spiky parts from any artifacting that might have happened. Let's switch, look at some of these other maps. And also it looks like this has been like heavily eroded, and it might have been, but there's some scale values here because these erosion and deposit values are pretty arbitrary. So it might be the case that this is like way too high or way too low. So these can be scaled down to kind of give a more nuanced view of what's going on. So that looks a little bit more appropriate maybe. But overall, that looks pretty good to me. The last thing I wanted to touch on was memory management, which can be a little tricky. All of these icons, or all these nodes with the orange icon, all the height map related nodes, they use OpenCL. And the way that I've implemented that is to never copy buffers unless the user explicitly says to. And this is just to make things fast, because the other option is to always copy buffers, which would be a lot less efficient and use a lot more memory. The way all these nodes work is basically it's one buffer, it's one sheet of paper that you're overwriting over and over and over again, which kind of makes sense intuitively. Like, why would you use extra paper if you can just overwrite the one you already have? But the issue is if you split the height map and you want to modify it in two different spots. So let's say I wanted to kind of view this as is, but I also want to blur it somewhere else. It's still just that one sheet of paper I'm overwriting and also wanting to look at somewhere else at the same time, and that can result in kind of undefined or weird behavior. So a very simple example, I'm viewing this, it looks fine. I can also blur it, okay, that makes sense. But if I were to evaluate this blur node and then view this height map, I'm actually going to get the blurred version. And you saw it change a little bit. It's not even the correct blurred version. It's kind of like one step behind. Again, just because it's giving that weird undefined behavior, like I was saying, and it just results in bad, unexpected things. So basically, wherever you need to branch the height map, you would need to copy it. And there's just a node, copy height map, and it's going to give you the original, like just basically a pass through of the original, and then that copied version. So I could plug this into here, and then if I plug this into this one, now I'm getting the correct original, but I'm still blurring it. You know, if I want to, I can still blur this, but it's not interfering because now I've just made a separate copy. If I just jump in here, actually you can see, so I'm allocating some new buffers and then writing that height buffer to it, and everybody has their own buffers.